Okay, so here we have a bunch of examples that are going to deal with percent predominantly. It's percent questions so that we could practice percent. You could see percent questions in a different context. It's not always going to be, what is 20% of this number? You know, like, it's not always that simple. So we want to see a mixed variety. We want to see it, you know, in a weirder presentation so that we're ready for anything. By using the language I keep using, I do think it'll be most effective. It'll help you out. For consistency purposes, I'm always going to show you, the same way. Here you have 3 questions that go to this data. We'll come back and look at the data in a second. Let's read the first question. What was the percentage increase? So that means if we have a percentage increase, we might have 100 and a certain amount, P percent, in my problem. If you get 105, that means it was a 5% increase, right? That's what these things mean. What was the percentage increase in the area covered by sod in Canada from the year 1991 to the year 2006? Okay, let's look at the table. Here's sod, area covered in sod. So where is that over here? Sod, area is in hectares. And from 1991, it was this, until 2006, it was this. So there's my information, and I want to know the percent change. You have a bunch of ways that you can go about doing this. For consistent purposes, I'm going to do it the same way I've been doing it. The new amount is what per cent, cent means 100, of the old amount. And we just fill in. So what am I filling in for the new amount? Good. Equals what? Well, that's what we don't know. X per cent of means multiply, the old amount. Oops. 26, sorry, my 6 was a 7. 797. Okay. Now, in the calculator, we're going to do some little math over here, get our answer. So, sorry, it's a little hard to see, but I'm going to divide both sides by what number first? Or maybe you want to multiply first, whatever. Which one do you want to do? Sure. What number do I multiply both sides by to start? Good. If you multiply by 100, multiply by 100. This 100 crosses out with that 100. It's a 1. Do I really even need to type that in the calculator? No, because it'll just add 2 zeros to the end of it or tack on 2 zeros. So times 100, I'm just for whatever reason typing it in. What do I do next? Good. 26,797. 26,797. Divide by 26,797 equals, and we get this number over here on our screen, 104.34. So X is alone now, gone, equals 104.34. If that's the number that went above 100, to have a percent increase, it's what you add to the 100 for your answer. So what percent do we increase? 4% increase. We just round to the best answer, 4% increase. The main formula you got to know in order to do it is your new amount. New amount is what percent of the old amount. And then you just drop each thing into the equation, and that's it. So it's 104%, I'm rounding, of the old amount. So we solved for what? What is the X? Okay, because we didn't know what that was. So we knew the new amount. The new amount was 27960. That was in the problem over here, 27960. That was the new amount. Then the original or the old amount, original or old, I'm just going to color coordinate it as best I could. Old amount that we didn't know, well, that's where that we started with, is that number over there. That was the old amount. They want to know what percent did we increase from that year to that year. Original was 1991. My new happened in 2006, right? My new amount is what percent of the old amount. So I didn't know what the percent was. I put in an X. Old I filled in right there, and new I put in that number. We solve, and we end up getting that x is equal to this number. If it's 104% of what it used to be, if you weigh 100% of what you weighed a year ago, I weigh 100% of what I weighed 1 year ago. You weigh exactly the same. But if you weigh 120% of what you weighed a year ago, you went up by 20% because you're all of what you were and you're 20% more. If you weigh 95% of what you weighed last year, you weigh 5% less than what you weighed. To be 100, you stay steady. You stay the same. You're maintaining. So because you got 104, they're rounding. They just chopped off this. That means you're 104% of what you were. So we kept that 26797, but we increased it by 4%. So it's a little bit more. So my 4% is my increase because I got a number 100 and something. Okay? So we'll see more of them as we go. What else?
Why did you cross out the 100? What did you just...
When I had the problem, I was here. So in orange, I'm circling how I started. Right? That's my new amount is what percent of the old. I multiplied both sides by 100. That 100's on top, that 100's on bottom. So they cross out. It doesn't distribute to this. That's what we were talking about today.
By multiplying the 26797 by 100 and then dividing the 2796 by that number.
You got 1.04.
Yeah, I got 1.04 and I said 1.01.
Right, but what you did is if you got that, then 1.04, if that was x in your equation, it would be up top. And that would be 1.04%, not 104%. Your brain just fixed it for you and automatically moved the decimal and you were okay. But really, because sometimes multiplying and dividing off by 100 or by 10, your brain autocorrects.
Yeah.
You're just like, I know what I need to do. But really, you have a little error in the work there, okay? The next thing over here, they're going to ask us about exponential versus linear. And I did mention that in each class. So a linear equation looks like this. That's linear. What else is linear? That's linear. If something's going up in linear, it looks like that. Going down in linear, it looks like that. If it was just data, linear data might look like this. Just random points. Linear data could look like this, just random points, but it's in a straight line if you connected it, right? Exponential data, like if you even think of these phrases, oh, the population was growing exponentially or the virus was spreading exponentially. Exponential is going to get more rapid as it grows, faster and faster and faster, so it curves and speeds up as it grows. That's exponential growth. Exponential decay, same idea, but it's getting smaller from left to right. It's decreasing from left to right. It's going down. And then the data will also have that look. It could be curved going up. It gets steeper as it goes up, or it could be curved and coming down. It's getting lower and decaying. So again, what does exponential look like? Let's highlight exponential in yellow. Is this exponential? Yes, it has this curve to it. That one's good. This one, and that one. The other ones are linear. How else can you tell? A lot of times, this is more ruled by like multiplication. Okay, there's this like multiplying factor over and over and over increasing or decreasing it. So you could be multiplying by a half or dividing by 2, or you could be multiplying by 2. Here, you're going to add or subtract a steady number every single time. All right, here, just looking at this, is this data a straight line or is it curving? It's definitely curving. Normally, I yell at you, don't connect the dots. This is just the highlighter for me to show you the curve. This is very, very compressed. If I stretch that out, the curve would be even more obvious. So this data is exponential. A similar survey is conducted in China. So this is China. And the results are shown in the scatter plot above. Okay, there it is. Which of the following statements is an accurate conclusion based on the comparison between the two countries' greenhouse product growth rates? So here's China, and China is exponential. We agree? This is Canada up here, total greenhouse products. That's linear. We said it's going up by how much every year or every 5 years? About 4 million, 4 million, 4 million, 4 million, 4 million, right? So both China and Canada's production of greenhouse products is growing exponentially. True or false? That's out. We just said China, yes, China is growing exponentially. Says they're both linear? No way. China, linear? Nope, that's out. China, exponentially, you're in. Here's the other one. Canada, growing exponentially? We said no. Canada, growing linearly, that part's fine. But China is not growing linearly. This is out. China, blah, blah, blah. Canada, growing exponentially? No, this is all sorts of bad. This, China's production of greenhouse products is growing exponentially, but Canada's is growing linearly. Oh, I cut it off. Sorry. Let me know if I do that again. Is that one good? Winner, winner, chicken dinner. That's it. Very little calculating to do here. Even if you had to guess on this question over here that was the actual percent question, if you had to guess, I guess you could take your old one, your old number here, and test it, but this is really time consuming. But if you were desperate, okay, you would take 2, 6, 7, 9, 7 times, if I want to increase, say, okay, here's a trick. If you're on the SAT and you want to do guess and check, always start with one of the middle two choices. So if I picked B, if I want to increase this by 24%, what do I multiply by? So you could either do 1.24 or really it's the same as 124 over 100. Equals 33,228. Is that answer too big or too small? Okay, it's too big. So if 24 is too big, well now these are all out. There's my answer. Right? If 24 is too small, now what could I cross out? 24 and A, 4. That's the benefit of when you guess and check, picking one of the middle two. You'll always be able to cross out 2 or 3 answers, or you hit the nail on the head, you got it right. Question? It might not be 3 pieces, because it's a little much. But, you know, it might be one question from it, but like I wouldn't give you the other ones.
Are you going in order?
I'm going in order of this packet. Okay, if we don't get to it, we're going to move quick now. So if we don't get to it, you'll interrupt me in a little bit. Okay, right? Because you said what time? 3 what? Okay, we'll move quick. All right, we're here now. Radioactive substance. This is just using reasoning. I'm not having you guys like know from Algebra 1, if you remember, y equals ab to the x power. A is the initial value. If you forgot this, totally fine. Okay, not a big deal. A is the initial value, and B is known as your, this is throwback Tuesday. This is your growth or decay factor, they called it. Growth or decay factor. And you probably just did little baby problems with this when you did like banking problems. Do you remember doing banking problems, interest rate, and you plugged it into a formula? That probably happened. You with me, guys? Right, Eva? Yeah? Okay. So here, radioactive substance decays at a rate, annual rate, we said yearly, rate of 13%. Is 13% going to be important to the problem? Yeah, of course. Okay, 13%. If the initial amount of the substance, is 325 grams, well, where's 325? Here, 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 and here. Every choice uses 325, right? Now, not everything uses 13%. We see 13 here and we see 13 here, but is 13 being used in the problem elsewhere? What does 87 have to do with 13? Yes, it's 100 minus 13. So that means if I start off with 100% of the radioactive substance, I lose 13% of it. How much is left? 87% of it every year is what I keep. Every year, you're keeping 87%. You're losing 13%. It's chipping away. It's wasting away. It's slow, but it's happening. Okay, you lose 13%, you're keeping that. Which of the following functions F models the remaining amount? That's the important piece. Remaining amount, 87% remains. Remaining amount of the substance in grams t years later. Every year, you're finding 87%. You get an answer, take 87% of that. You get an answer, 87% of that. So what do you keep multiplying by in the problem? 0.87 or 87%, which means 87 over 100, which is equal in your calculator, I promise, to 0.87. Even as a decimal, that's tenths, hundredths, 87 hundredths, 87 hundredths, right? So that's what you keep multiplying by. So the choices with the 13 are out. If the 87 keeps getting multiplied, that's the one that gets the exponent, because the more you multiply by something, the higher its power, right? If you do 2 times 2, isn't that the same as 2 squared? Or 2 times 2 times 2, isn't that 2 to the third? So as you multiply by something more and more, it grows exponentially. It gets an exponent on it. So the right answer is day. All right? Question on this? Go ahead. Say again? Oh, yes. You could take this. All right. I gave you one in class today.
Yeah, but I haven't looked
Oh, okay.
No.
Girl, all you do is leave your stuff everywhere. Every day you come in, I left my phone, I left my notebook, I left my water.
She left all of us out. It was rough.
A rectangle. Now, today I went over this in a lot of your classes the long way. I'm going to do it the cheap way right now. Ready for the cheap way? We love the cheap way. But the real way is important, but the cheap way is great. When we're doing these rectangle problems, the SAT loves them. What shape do we start with? Yeah, the square is still a rectangle. Totally fine. What dimension square should we do? 10 by 10. What's the area of it? 100. It's very easy to play with percents if it's a 10 by 10 and it's 100 area. So this is going to be my original rectangle. Not a great drawing, sorry. 10 by 10 are my dimensions. This can be my width is this side, my length is this side, okay? And my area is 100. There it is, beautiful, right? Now, new rectangle. A rectangle was altered by increasing its length by 10%. What's 10% of 10? 1. 10 % is 1 out of 10 if I reduce it, right? So 10% is 1 out of 10. So if I increase this by 10%, what's my new length? 11. If you did it in a calculator, the formal way, if you struggle and you're like, I don't wrap my head around this, the new amount is 110% of my old amount. Go on your calculator, 110 divided by 100 times 10, and you get the 11. Okay, I promise. Either way, that's 11. The width decreased by p%. So I don't know what this is, question mark. I'm just going to do it the cheap way, question mark. I don't know what it is. We're being real cheap. The area of the rectangle decreased by 12%. If it was originally 100, what's 12% means 100? 12 per 100. So if it went down by 12, the new area is how much? 88. You subtract 12. We want to know about this width. 11 times base times height, length times width, right, is area. Length times width is area. 11 times what is 88? So that means my width will become 8. What was my width? Original width was? It went down by how much? Well, by what number first? Went down by 2, 2 out of 10. 2 out of 10 is how much out of 100? 20. So, final answer, 20, because they want to know, if these alterations decrease the area of the rectangle by 12%, what is the value of P? P is what we decrease the width by, what percent? That was the cheap way of doing it. Really cheap and easy. Not complicated, no formulas, no nothing. Question?
Does that work for any rectangle problem?
Essentially. Like, not like in life, like if they told you the dimensions of it originally, sure, that's different. Because they might not ask you by what percent did it change. They might ask you how much did it change. Then you have numbers already. So you don't have to be like abstract. You don't have to be general. You'll have numbers. But when I do with the formulas, because I don't have numbers, I'm just generalizing. Okay? Next, do you see how this is set up? Now, you guys don't really know much about this yet. We'll learn about this later this year, but I figure let's get your feet wet.
It's gonna be on the test.
Not like where I would expect you to know this, but honestly, you could narrow down the choices. It's really, you don't even need that next lesson to get it right, okay? You want to guess C? Anybody have another guess? What would your second guess be if I told you C was wrong?
D.
Okay. Do you guys agree with her?
I haven't read that question.
All right, so let's read it and then you have to tell me if you agree. Ready? Oops, over here. In planning maintenance for a city's infrastructure, so infrastructure like dealing with your roads, your bridges, your tunnels, your traffic, everything that's going on, your subways, your trains, a civil engineer estimates that starting from present, the population of the city will decrease by 10% every 20 years. Now that already, what does that tell you? Decrease by 10%. What's probably going to be in the problem? What do you think? We're dealing with how many people are left. Say what?
Would it be the 0.9?
Yeah, I like the 0.9, right? 0.9 because it's 90% remains, right? So it's 100 minus 10. That's where we get this 90%, which is also equal to 90% or 0.9 or 0.90.
So we automatically cross out 1 A and B.
Those aren't looking good, right? I'll get rid of them. Process of elimination. So Jen's answers look good. She has the 2 most reasonable answers on her list. If the present population of the city is 50,000, I mean, they all have 50,000 right there. Guess that's where it goes, right? Like, even if you didn't know, now you know, okay? Which of the following expressions represents the engineer's estimate of the population of the city T years from now? Here's how you do this. Ready? This is not the full lesson. But there's the 20. Ready? The population is going to go down 10% every 20 years. How long will it take for it to go down 10%? Okay, if I plug in 20 for time, look at my choices. Do you take 90% of it? What's 20 over 20? 1. So that means you're going to take 90% of it one time after 20 years.
The other one's like 400.
Because then, yeah, you're going to take 20%, 90% of it to the 400th power. So that means you took 90% of it 400 times. So that's why you end up dividing it. So it's a little weird. So the best way to do it is take that number and fill it in. If it's every 20 years, that means 20 divided by 20 is 1. In 20 years' time, you only deducted or decreased it by 20% or 10% once. So I do like choice D. Okay? Do you see that little like division step they threw in there? This would be if... Right, and it looks good, and people like it, but what it's doing is it really increasing it. So this is like saying it decreases by 10% 20 times a year.
Okay.
So in 1 year, you plug in a 1 for time, 20 times your population decreased. So like every X amount of days, it was like, ended up being every 20 times a year. That would be what we use. So in 1 year, you did it 20 times. You know, like if you get paid monthly, once a month, you get 12 checks a year. Well, then you might have a 12 in there because you're doing it 12 times a year.
Yeah.
So it's like increasing that frequency. But if you're dividing the frequency out, like it's not every year, it's every 20 years, it's going to be there. We'll have a formal lesson on it. But when you're desperate on a test, you see how I like just reasoned it out by plugging in 20. So plug in this big chunky number, especially one already mentioned in the problem, to reason it out in your head. Take your time. All right? The population of squirrels in a park has been doubling every 15 years. What kind of growth is this? Exponential growth. Which of the following statements best describes the type of function that best models the relationship between the population of squirrels in the park and the number of 15-year time periods, blah, blah, blah. Okay. So, right, they're not linear growth. So again, eliminated. So we quickly learn by just doing this one packet, like how many new skills do you have to like chip away at choices, right? Exponential growth, because the population of, look, I'm comparing, squirrels is increasing by the same amount, by the same percentage. Is it by the same amount or same percentage if it's doubling? If you keep doubling the population, right, you're going up by 100% every year. So, B. Go ahead.
So, for the one that we did earlier, and we were doing. Let me see if I can find her. For number 28, like where it was sort of comparing, like every 20 years. How would we write that? What would it look like if it doubled every 15?
Okay, so if we had to write the equation, which they didn't ask us to do, but that's fine, it would be y equals ab to bx is that format, right, that I brought up before. A is the initial amount. So I don't know how many squirrels were in the park originally, so I'm going to call it I for initial amount. Okay, y is the amount of squirrels later. If you're doubling, okay, if you go up by 5%, you would do 1.05. If you're doubling, what percent are you going up by? 100. And what's 100% plus 100%? It's 200%, so you would put a 2. Every 15 years, so here's your time. If it's every 15 years, it's time over 15.
Oh, okay.
Because in 15 years, it'll double once. In 30 years, it'll double twice.
Okay.
In 45 years, it doubled 3 times. So this doubling happens every 15 years once.
Okay.
30, 45, 60, it'll make sense that way. That's the initial amount, how many you started with, and that's how many schools we have.